Hello students, welcome to assignment 3.7. I hope you're having a good day, whatever time of day it may be for you, whether you're watching this in the morning, the evening, the afternoon, the middle of the night. Hey, hope all's going well with you. So we are going to switch gears with assignment 3.7. Everything we've done in this unit 3 so far with quadratics, we have dealt with what's called quadratic equations. Okay, quadratic equation, of course, we have our x squared term. And with a quadratic equation, typically you want to get that equation equal to 0. This is called a quadratic equation. And quadratic equations are meant to be solved. The directions to a quadratic equation will typically say, solve this equation. Find the specific values of x that make this equation true. Well, you'll notice a word change today. Today we're not using that word equations anymore, quadratic equation. Today we're talking about quadratic functions. And the difference is, whereas a quadratic equation, typically you want it to be equal to 0, a quadratic function is actually equal to y. And so not only a quadratic function, not only will it have the x squared and a linear term x, it's also going to have this second variable, y. Now, functions in general are not meant to be solved. There's no way that you can solve this. Instead, they are meant to be graphed or kind of analyzed amongst all the different x values. Okay, so I like to say it like this. When you're solving an equation, you're trying to find like the one or two specific x values that make this true. Whereas if you're graphing a function, you're actually trying to analyze what happens with all of the x values. The idea is you could plug any x value into here, and you want to analyze what happens across all the different x values that you could plug in here. Okay, so you'll notice question 1. We're going to do questions 1 and 2 together. Question 1 then, we have a function. This quadratic here is equal to a y. And so ultimately it's going to be meant to be graphed. So let me show you how to do this. So first off, we're asked to find three things: the vertex, the zeros, and the y-intercept of this function. So let's start with the vertex. Now the vertex has its own formula. The vertex formula looks like this. It's similar to the quadratic formula, but it's a lot simpler. Okay? And this will give you the x value of the vertex. X value of a vertex. So I find my a, b, and c just like I did previously. I'm going to say a is equal to 1. I could put a little 1 here. B is equal to -6, and C is equal to 8. Well, let's plug in our values here. So the opposite of B, I'm going to take the opposite of -6 over 2 times A. Now the opposite of -6 is, of course, +6. And then before I divide, as I'm getting my calculator out, I really need to take this 2 times 1 is 2. Before I even try to divide this. Now luckily this one I can do in my head. 6 divided by 2 is 3. And so the vertex of this parabola has an x-coordinate of 3. Now to find the y value, what we're going to do is now we're going to take this 3 and plug it back in to my original function. Okay, so instead of writing y equals x squared minus 6x plus 8, I'm now going to plug this 3 in. Now I'm going to say y is equal to 3 squared minus 6 times 3 plus 8. And here's where a calculator can be handy. Hey, get in the habit. When you plug numbers into a quadratic, just get in the habit. Put those inputs, like the 3, put them in parentheses. So I'm going to do in parentheses 3 squared minus 6 times 3 plus 8. And the reason why I really want to tell you to use those parentheses, it matters a lot with negative numbers especially. Okay, so just get in the habit, put that input in parentheses. The y value comes out to -1. So this is called the vertex of my parabola. It is going to be 3 for the x, -1 for the y. And when we go to graph this, we'll talk a little bit about what the vertex means. Okay. So now, but here's your key. This is your formula for vertex. That will give you the x-coordinate. and then take whatever answer you get, plug it into your original function to find the y-coordinate. Okay, I'll show you real quick because you might be wondering what the vertex is. The vertex of a parabola would be when you graph quadratic functions like this, you get this parabola shape. The vertex would be the point right here, where the parabola actually changes and switches direction. The parabola is also symmetrical about this point. So everything to the left of the vertex is a mirror image of everything to the right of this vertex. All right, let's focus now on what are called the zeros or the x-intercepts. The zeros or the x-intercepts of a parabola are the 2 points where that parabola crosses the x-axis. Okay? Now the way you find the zeros, guess what? We're still going to use quadratic formula. The way we find our 2 zeros is our good old quadratic formula that we learned in previous lessons. Now I can talk to you briefly about why this works. So remember, the x-intercepts, these would be the values of the function when the y value is equal to 0. Okay, and so essentially you're saying, hey, if this y was a 0, find the x values that go with it. Well, that's exactly what you do in a quadratic equation. You solve the equation when it's equal to 0. Okay, so the way you find the zeros or the x-intercepts, we're just going to use this formula. All right, I think I have my little sheet here. Let me take a time out. So my values again are 1, -6, and 8. So if A is 1, B is -6, and C is 8. Let's crank this out. So put -6, -6, 1, 1, 8. Okay, we want to start with the square root. And here again is where it's so important to put these numbers in parentheses. Make sure in your calculator you're putting this -6 in parentheses. And a reminder, I like to kind of do this all in one step, the -6 squared minus 4 times 1 times 8. Okay, so everything inside the square root turns out to a 4, but I have not taken the square root yet. So now I need to make sure I take the square root. The square root of that is, the square root of 4 is 2. All right, this entire square root simplifies to a 2. So I'm going to place the 2 right here. Here I'm going to take the opposite of -6, which is +6. And then on the bottom, I'm going to take 2 times 1 is 2. So my two solutions from here, my first answer will be 6 plus 2 divided by 2. Put that in parentheses. I've got to do 8 divided by 2, which is 4. Now my second answer is going to be 6 minus 2. Put that in parentheses, divided by 2. That is 4 divided by 2, which is 2. So in this context, the 4 and the 2, these are called my zeros. So the answers here, we got x equals 4, x equals 2. Now the x-intercepts would actually be written in this form. And it doesn't matter which order you put it in. I'll put the smaller number first, but the order doesn't matter. Here's how you would actually write it. You would say 2, 0, and 4, 0. All right, and then the easiest is the last. The y-intercept is the easiest thing in the world. The y-intercept is simply the c value. C. There's the whole formula. You just look at C. C is equal to 8, so the y-intercept is 8. Now technically the y-intercept would have a y value of 8, an x value of 0. So basically just take the number C. Always put a 0 in for the x, and then take whatever your value is for C and plug it in for y, 0, 8. See, this works because if you were to plug a 0 in for x and plug it in here and here, these two terms would vanish and you'd simply be left with the 8. So 0, 8. All right, so let's talk about what this means on a graph. So in question 2, we have to take these answers that we have here and select the correct graph. Okay, well first of all, let's start with the vertex. 3, -1 is the vertex. I need to find a graph that has a vertex of 3, -1. And you know what, right off the bat, here, This graph has the vertex 3, -1. None of the others have the vertex in the right spot. So right off the bat, I know the answer is A. Okay, but let's kind of look at the rest of our answers. So our zeros were 2, 0 and 4, 0. That is right here and right here. 2, 0 is an x-intercept. 4, 0 is an x-intercept. These are called the zeros. Now, my y-intercept is 8. So here's where my graph kind of dead ends here. You can't really actually see this y-intercept in this particular example, but if this graph were to continue upwards, I promise you it would cross our y-axis at 0, 8. Okay, so the y-intercept of a graph, kind of go back to my little drawing here. This graph would keep going up and up and up until it hit the point 0, 8. All right, so my graph, I had the vertex 3, -1. My zeros were at 2 and 4, 2, 0 and 4, 0. And then my y-intercept up here at 0, 8. Okay, at the end of this video, I'm going to show you how you can check your answers on using Desmos. Desmos is a great way to check your answers on this. But for now, let's actually do one more question. Let's get one more question started together. And actually, let me show you this real quick on question 8. Just a little hint. If you ever have an A value that's negative, so here in question 8, we would say A is -1, B is -2, C is +2. If you ever have a negative A value, your parabola is going to actually open downwards. It's going to be, you call it a downward facing parabola. I'm just going to say a downward parabola. If you ever have a negative A values, your parabola is going to open downwards like this. I can tell you right now, the answer to number 8 is either going to be A or B, because a negative A value means that parabola will open downwards. Okay, so just a little hint on that on like question 7 and question 8. Okay, but I wanted to go through question 9 and show you two things you really got to watch out for. All right, so when you go to find the vertex, please make sure, so here's our formula. Let's plug in our numbers. So here, A is 1/2, B is -2, C is 6. Please, please, please make sure. So we'll plug our -2 in for B, and then we'll plug 1/2 in for A. Please, please, please make sure, and if you're using a calculator, don't try to do all of this at once in a calculator. You will get it wrong if you try to plug all this in at once. You need to find the top and the bottom separately. So +2 on the top. So I need to find the bottom separately. 2 times 1/2 is just 1. And so then once I've figured out the top and the bottom separately, now I can divide. Now 2 divided by 1, that's easy, that's 2. Okay, so this would have an x value of 2. But see, here's the mistake a lot of people make. A lot of students will try to type all of this in at once, kind of ignoring the rules of fractions, and they'll just try to type it in all at one time, and you will get the wrong answer if you do that. Break it down into, you're going to find the top, and then you find the bottom, and then you divide at the end. Okay, so there's a start to question 9. You'll still have to find the y value to finish up, but I'll let you do that on your own. Okay, plug that 2 back into the original function. That will allow you to find your y value. Okay, now zeros. I want to talk about zeros for a second here. I'm not going to work out the whole thing here, but I want to just give you a hint. Actually, let me work it out on the side. Okay, I want you to see this. If you ever go to find the zeros of a quadratic function and it comes out imaginary, here I do, in parentheses, -2 squared minus 4 times 1/2 times 6. Well, it comes out to -8. All right, and we know this is going to be imaginary because you can't take the square root of a negative number. All right, so what we've learned to do in the past is just write this as like I radical 8. But at any rate, if you ever have imaginary zeros here, then what's going to happen is that means that your graph does not have, it doesn't have any x-intercepts. Okay, if your zeros are imaginary, then it's a guarantee there are no x-intercepts. What this is going to mean, and I don't know the exact answer, but I can promise you this. Your graph your parabola is going to look kind of like this, in the sense that this parabola is not going to cross the x-axis. It's going to have 0 intercepts, 0 times that it crosses the x-axis. If you ever have imaginary zeros, your graph will not cross the x-axis. Okay, I know here I'm going to have my vertex at 2 comma something, but yeah, it's never going to cross the x-axis. So as I start to look at my choices for number 10, my choices start to make sense. Notice that none of these choices cross the x-axis. Okay, and that's why, because because the zeros are imaginary. They're not going to have any x-intercepts. Okay. Well, here we go. Look, here's the y-intercept is 6 here. Here, you see we're in luck in this one. The only graph here of my choices with a vertex at 2 comma, looks like it's at 2 comma 4 is D. So I know my graph's going to be D on this one. Well, look, it doesn't have any x-intercepts, and that makes sense because the zeros are imaginary. So here's how we're going to check our answers to questions 1 and 2 using Desmos. Now, when you first type in your formula, negative 16x squared plus, it was going 88 feet per second, so plus 88x. It had an initial height of 2.5. When you first type your formula into Desmos, it's going to look, I think, a little awkward. And you could try to like zoom out and see like how high this parabola goes, but even that I think starts to look a little awkward. So let me show you how to set the window. If you want this graph to really look good on Desmos so you can check your answers, I'd recommend going to this wrench up here and then adjusting your x-axis, all right? So the x-axis here is the number of seconds that the football is in the air. Well, we know that it's going to start at 0 seconds, and then we know like the best NFL punters can punt at 5 seconds in the air. So maybe I'll go a little bit beyond that, like 6 or 7 or 8. You know what? I'll do it to like 8 seconds. Okay, that kind of puts the 5 towards the middle of my graph. Now the y-axis then is the height of the football in feet. I know that the answer we got for our vertex was 123.5. So I'm going to try going higher than that, like 150. But then look how much better this graph looks now. Here you can really visualize this football flying through the air. Now at the very beginning, move that point just a little bit. At the very beginning, it starts, okay, at 0 seconds when it's kicked, it's 2.5 feet off the ground. That's where the punter kicks it. But then watch, you can imagine this 1001, 1002, 1003, 1004, 1005, 1006. Here you can check the vertex. We were correct. We said it was 123.5 feet was the highest this football went. And then we can check the 0. We were also correct. We said the football would hit the ground at 5.528 seconds. But isn't that a wonderful visual? You can see how, man, gravity, parabolas, quadratic functions model gravity perfectly. It's almost like the language that gravity was written in just perfectly is modeled by quadratics, a variable being squared. All right, so there we go. There is your quadratic functions at work. Best of luck on this assignment.